Okay, I should be audible. So first, we had few questions left from week four. We will first discuss them, and then we will proceed to our week five. And meanwhile, if you have any questions from the past week, you can just type in the chat box or unmute yourself and ask me anytime. Okay, so the question is, for the circuit shown in figure, the values of device parameters of the MOSFET are given by kW by L is given as 1 milliampere per volt square. Threshold voltage is 1 volt. Lambda, that is channel length modulation parameter, is 0. That is, there is no channel length modulation. That means if I draw IDVD, it will be flat after saturation. And if there was a channel length modulation, this one will be the device behavior. Okay, so we're not going there. We'll just focus on solving this question. The values of the components are given by R1 equal to 60 kilo ohm. This is 60 kilo ohm. R2 is 20 kilo ohm. And RD, which is the load resistance, is 2 kilo ohm. That's the drain resistance. And VDD is 12 volt. Okay. So we need to find small signal voltage gain. That is V output by V in for the circuit. Assume the signal coupling capacitors are shorted. That means for the frequency of interest, that is at the frequency we will solve this question, we need to consider capacitance as short. Okay, so let's start. Okay, now if I draw the small signal equivalent circuit, so this will be V in, this will be R1 parallel R2. Okay, so this will be GM V in because potential across parallel components should be same. So here it will be V in also. And you have RB here, and this is V. Okay, so from the KCL, we can write V output by V input is equivalent to GM RD. So this is my gain. All right. Now I need to find GM. So from MOSFET equation, IDS is equivalent to kW by L 2 times VGS minus VTH n whole square. This is drain current equation. Okay, so if I need to find Gn, that will be given by dIdL by dVGS. So kW by L VGS minus VTH n. Right? Now this term is known. This is known to us. This is also known. What is this? VGS Can you find VGS? Yes, right? VGS, this is this is your gate and this is your source, or this is your source. So VGS is the DC voltage across R2. So by simply using the voltage divider, I can write VGS as R2 divided by R1 plus R2 multiplied by VDD, that is 12 volt, right? That is 12. And R2 is 20K divided by R1 is 60, 60K plus 20K multiplied by 12. So VGS will be 20 by 80 multiplied by 12. So that is 3 volt. So this is your VGS. Now you can find GM. Therefore, GM will be kW by L. kW by L is 1 milli, that is 10 to the power minus 3, multiplied by VGS, that is 3, minus VTH is 1. So GM is 2 millisiemens. Right? Now we need to find gain. Therefore, gain is GM times RD. This 2 milli multiplied by RD. RD is 2 kilo ohm. Kilo and milli will cancel. So it is 4. So the correct option is 4. I hope this was easy. You let me know if you have any questions. If you have any doubt, please don't be afraid to ask. Just type in the chat. Okay, so let's move on. Okay, the question says find the output resistance of the circuit. Assume signal coupling capacitors are shorted while doing the small signal analysis. Select the correct option from the following. Let me just draw the circuit and I will ask you to give me the answer. It is easy, we have done it already. Small signal EC equivalent circuit. Let me just draw it. I need to find this resistance. Can you tell me what is our out? I will give you 3-4 minutes. Let me know what is our out. Yes, right. That's RD, right? Yes. If when you find R out, what you will do? You will attach a test source, IX, and potential VX. And what you do at the input? Ground it. That means VGS is 0. So there is nothing going in here. So IX will flow to RD. So Vx will be IXRD. That means Vx by Ix will be RD. That is your R out. Now, can you tell me what will be the input resistance? Similarly, you can find the input resistance. You can give me the answer. Exactly, right? Now you need to attach a source here. It will simply flow through the R1 parallel R2. So input resistance is R1 parallel R2. Correct. Absolutely. Okay, so we have done this type of question as well. Find the value of signal coupling capacitor C1. We need to find the value of C1 such that the lower cutoff frequency, the amplifier is 10 Hertz. So the frequency lower cutoff FLC is 10 Hertz. Okay, so let me just draw the equivalent circuit. This is your equivalent circuit. And I told you that lower cutoff frequency is given by your input capacitor. Okay, so what you do is, one second, know that when you have to find, okay, so when you have to find the cutoff frequencies, and just remember that cutoff frequencies are attached to the particular capacitors. Here, for example, to find the lower cutoff frequency, which is given by capacitor C1, we need to short the output capacitance. So I have shorted here output capacitance, that's why it's V out here, and I will only use C1 to get the frequency response. So VGS, this is C1. So VGS, what will be VGS? Then what will be VGS? Simply a voltage divider here, right? It will be R1 parallel R2 divided by R1 parallel R2 plus XC1. What is XC1? It's the reactance of the capacitor. This will be Vn. Okay. Now gain, as from the previous question, we know gain is Gm times Rd, but now we have this part as well. So it will be multiply R1 parallel R2 divided by R1 parallel R2 plus XC1. Do you know where did this term come from? Simple, right? You need to find V output by V input. Here you need to find V output by V input, but from this term you will get V output by VGS as GMRD, and then at VGS, for VGS you need to substitute. Let's say this is alpha times Vn, so this will be alpha times Vn is equivalent to GMRD, and this alpha goes here. So that's what I have written. This is alpha. Okay. So this is your V output by V input. Let's just simplify a bit. So GMRD is 4. So your gain will be 4 times R1 parallel R2 divided by R1 parallel R2 plus XC1. And for the pole, the XC1 will be equivalent to R1 parallel R2. I'm just directly writing it. So this will be omega times C1 inverse is equivalent to R1 R2 divided by R1 plus R2. This is 60K multiplied by 20K divided by 80K. 1K will cancel. 4 and this will be 15. So this means 15K. So that means omega C1 is equivalent to 1 by 15K, right? So C1, we need to find the capacitance at 10 hertz. So C1 is equivalent to 1 divided by 15k multiplied by 2 pi multiplied by 10. Omega is 2 pi f, right? This is the definition for omega. And f is given to us in the question. That is 10 hertz. Okay, so this will be, let's just calculate it. 1 divided by 50 divided by 4 divided by 3.14. Okay, so this is approximately approximately 1 microfarad. So this is the value of the capacitance we will get. Okay, so this is how you find the cutoff frequency and the relative capacitance. Directly, if I need to directly calculate it, what I will do is just say for the capacitor it is omega C 1 and multiply it with the equivalent resistance that is here R1 parallel R2. This is your resistance after C1 and substitute it equivalent to 1 and you will get your answers. We will see such simplifications in the next questions or in the next week. Let's for now use this. Okay, so the last question from the previous week was find the power dissipation of the amplifier including the biasing circuit. Including the biasing circuit means you have there may be some current flowing through this these resistances. So you need to include that as well. Okay. So power is simply voltage multiplied by current. Okay. So now we have two powers. This is one due to the current flowing through here and one here. This is IDS. Let's call this IB. So powers will be P1 plus P2. And what is P1? That will be VDD. And total current drawing from this is IDS, right? And which is given by IDS is KW by L, L VGS minus VTH whole square. So IDS is 1 milli by 2, KW by L is 1 milli, VGS is 3 minus 1 whole square, that is 4 milli by 2, which is 2 milliampere. So P1 will be VDT, that is 12, multiplied by 2 milli, that is 24 milliwatt. Unit of power is watt. Now P2. P2 is VDD multiplied by biasing current. And what is the biasing current here? I have a resistor here, R1, and I have VG here, which I know. This is VDD, so directly using the Ohm's law, this will be VDD minus VG by R1, which is 12 minus 3. 3 is your VGS, right? We have calculated it. So this will be 60K. So IB is 9 by 60 milli and comes out to be this is 3 by 20 and therefore P2 will be 12 multiplied by 3 by 20 milli, and it comes out to be 1.8 milliwatt. Okay, 60 is original. Okay, so this is P2. Therefore, total power is P1 plus P2, which is 24 milli plus 1.8 milli watt. So that is 25 into. So this is how you find the power dissipation. So if there are no questions till now, we can move to the questions which are for week 5. From this onwards, this is week 5. If you want me to repeat anything, please let me know, or else we can proceed. Okay, so again, as in the previous weeks, we start first with the BJT. This is a 10 transistor. Okay, this is a common emitter amplifier. Various parameters are given, such as VCC, 12 volt, okay, beta, that is IC by IB. This voltage is 0.6 volt, this is at zero point 0.2. These values will be used in the questions which follows. And early voltage is very high, that means when the early voltage is very high, that means characteristics are again like this, like in the previous one. Okay. Hmm. RE, RC, R1, R2, and these all values are given. C1, C2, C1. Find the lower cutoff frequencies. Now the question. And there's the question. So, the find the lower cutoff frequency of the amplifier, assuming the parasitic capacitances, that is C pi and C mu, are negligible. Select the closest option from the following. I will draw the equivalent circuit and I will want you to just give it a try. Okay, this is equivalent circuit. This is total equivalent circuit. And now you need to find lower cutoff frequency. So what we will do is, ignoring all the capacitors, just focus on the capacitor C1. So I will short all these capacitors and I will give you a simplified circuit that is like this. Okay, now I need you to find the cutoff frequency. Give it a try. I'll give you 5 to 6 minutes to give it a try. Do one thing, just find V in by Vs, find V in by Vs, and you will get the denominator term in terms of omega C1 plus something. Okay. Then you just need to equate this term and this term. This will give you a pole. And from that pole, you will get your answer. You will get some omega C1 multiplied by equivalent to C. It's equivalent to or greater than 1, which will give you lower cutoff frequency. Just give it a try, and then after I will show you the answer. How to do. Take your time, 3, 4 minutes, 5 minutes, and let me know if you need any help. Parameter values. Here are the parameter values. You just need R1. Just give me the equation. Just give me the equation. Still, you can write the values. R1 is 8.4 kilo ohm. R2 is 3.6 kilo ohm. Because for R pi, we need for the step to calculate, which I will show later. Just give me the equation or tell me how you have done it. Okay, let's suppose R pi. I know the answer for R pi. I will give you the value of R pi. R pi is 3.46 kilo ohm. R pi is 3.46 kilo ohm, and R1, R2, R1, R2, R1 is 8.4, R2 is 3.6, 3.6 kilo ohm, 8.4 kilo ohm. Just do this, huh? Now you can do this. You don't need anything else. RS, you need RS. RS is 81. Give it a try now. No issues. Oh, I tried that. That's what matters. Okay, so just let me just show how we can do it. So this is the equivalent circuit. We use the same circuit. As I told you that what we need to do is we need to find the equivalent resistance across the capacitor. That is this resistance and add them up. So what is this? Total equivalent resistance will be Rs plus what is this? R1 parallel R2 parallel R5 divided by R1 parallel R2 plus R pi. So for that we need R pi, which is given by VT by IB. You need to remember this formula. We have done this in the previous session. R pi is given by VT by IB. And after you find equivalent resistance, we'll directly use omega C1. Our equivalent is greater than 1, which will give you the lower cutoff frequency as 1 divided by 2 pi R equivalent C1. This is a direct way to get the answer. For R equivalent now, we need to find R pi. And to get to this formula, we can do is just use the voltage divider here for V in terms of Vs. That is a transform, and you will get the terms in terms of capacitance and also R1 plus R2, R and Rs, and you will lead to this formula at last. So try it uh, yourself later, and if you find any problems, you can let me know tomorrow. We will have a session tomorrow as well. And for now, just remember that a frequency, cutoff frequency related to a particular capacitor can be found like this. Just take the capacitor, short every other capacitor, and find total resistance across it from left to right. In the left, it is Rs, and in the right, you have a parallel combination of these two resistances. Okay, so the total resistance will be Rs plus this term. Okay, now when we have this term, we know all the values of R1, R2, Rs. Just we need to find R pi. How do we find R pi? R pi is dt by id, right? Dt by id. So we need to find ib. Okay, so I will do a DC equivalent circuit, which is simply you need to open the capacitances. So what we are left with, there is your DC equivalent circuit, and we know all the values. VCC is 12 R1 is I just need these two values. VCC is 12 volt, and I need beta, which is 400. VBE is 0.6. I need these values. So now what I will do is I will use a KVL in this direction. Okay, from VCC, that is VCC minus voltage across resistance 1 minus VBE, this is base, this is emitter, okay, minus VRE is equal to 0. Alright, so VR1 we can find from the voltage divider. VCC is 12. This will be R1 divided by R1 plus R2 multiplied 12. VBE is given as 0.6 minus VRE is IE RE equal to 0. Fine. Okay, so VR1, which is R1 divided by R1 plus R2 multiplied by 12. What is R1? That is 8.4 kilo divided by 8.4 kilo plus 3.6 kilo multiplied by 12. Just 8.4 multiplied by 12 divided by 12. This is 8.4 volt. So VR1 is 8.4 volt. So what I will get from this equation is I will get IE. So this will be 12 minus 8.4 minus VBE, that is equal to IE. RE is 2 kilo. RE is 2 kilo. So IE will be 12 minus 9, that is 3 divided by 2 kilo, which is 1.5 milliamp. So this is a emitter current, right? Now we know from BJT IE is equivalent to IC plus IB, right? And IE, what is the formula for beta? IC by IB. So I can write IC in terms of beta IB. So this is beta IB plus IB. So this means IB is equivalent to IE divided by beta plus 1, which is IE divided by beta is 200, 1. So IB will be equal to IE, we calculated as 1.5 milliampere divided by 201, which comes out to be, if we just divide it quickly, 1.5 divided by 201 comes out to be 0.00746 milliampere. Okay, so this IB will be used to calculate R pi, which is VT by IB, which is 26 millivolt VT, that is the thermal equivalent at room temperature, right? This is 0.007. That is out to be 3.485 kilo. Now we have R pi. What next we need to calculate? R1 parallel R2. We know R1 is 8.4 kilo ohm, R2 is 3.6 kilo ohm, divided by 8.4 plus 6, that is 12 kilo ohm, 1K, 1 kilo cancel. It comes out to be 8.4 multiplied by 3.6 divided by 12. This is 2.52 kilo ohm. Now, what next? This is in parallel to R pi, R1 parallel R2 parallel R pi divided by R1 parallel R2 plus R pi. We need to calculate this. It will be equivalent to 2.52. Sorry, this is multiplied. This is multiplied here. Multiplied by 3.485. Both are in kilo ohm divided by 2.52 kilo ohm plus 3.485. 1K millifernsec, and it comes out to be 1.45 kilo ohm. Now you have this resistance, therefore, as I told you, total resistance will be R equivalent will be RS. Let me call this total resistance I calculated as RN. RN, so total will be RS is 80 ohm plus this 1.45 kilo ohm, right? So let's assume that R equivalent is, because 80 kilo ohm is very less there. 80 ohm is very less than kilo ohm. So now moving to this formula here, now lower cutoff frequency will be 1 by 2 pi R equivalent C1. I know now R equivalent, C1 is also known. I can directly use now as 1 divided by 2 pi 1.45 kilo ohm, and C1 is 10 microfarad. Given the question. So FLC is critical. Calculate it, and it turns out to be greater than 9 hertz. So this is your lower cutoff frequency. Okay. So any questions or doubt in this procedure? We'll be using these formulas directly in other questions as well. Okay. Then tell me its cutoff frequency. Cutoff frequency means after that frequency the capacitance acts as a shock. Now for this I told you the procedure. Now tell me what will be the cutoff frequency for the circuit. Simple exercise. Okay, take your time. Okay, what we did was like this. Our figure R equivalent as R1 plus R2, that is 4 kilo, and then use the formula omega R equivalent C1 greater than 1, and this is 2 pi f cutoff frequency is greater than 1 by R equivalent C. So this will be Fc is equivalent to 1 by 2 pi multiplied by 4K multiplied by C1. So use the formula and give me the answer. These are not in parallel, right? When you sort the capacitance, these will be in the series. Okay, 0.04 watt. That is the unit of the frequency. You always write H in capital, Z in small. Okay, so we can do the questions of this side, right? Now let's move to the next one, which is upper cutoff frequency. Find the upper cutoff frequency of the amplifier as shown in figure this, and that is the same figure. Assume the parasitic capacitance are negligible, that is C pi and C naught, mu, we need to ignore them. We need to find the upper cutoff frequency. Okay, let me just draw the circuit. For the upper cutoff frequencies, those load capacitance, okay? So this will be your, okay, can you calculate it now? What is the resistance across this capacitor? On the right, there is nothing. And on the left, what is the resistance? Look here, this is grounded, so that means this is grounded. So there will be nothing. So the resistance is RC. So can I use the formula directly? Omega RC CL is greater than 1. So this means upper frequency will be equivalent to 2 pi times RC multiplied by CL, right? So that will be 2 pi multiply RC. RC is 4 kilo ohm and CL is 100 picofarad. This is 4K multiplied 100 picofarad. Just take the calculator and calculate it. Let me know the value. You understood the use of formula, right? Just tell me the value. It will be around 400 kilohertz. Okay, cross check it whether the value is same. Drawing the equivalent circuit. We need to find the gain. First, I will draw the equivalent circuit. I hope you are able to now draw the equivalent circuits. We have drawn so many in the past few weeks. I hope this is easy now for you as well. Look here, I just used CL and I shorted the other capacitances because what is the value of omega given here? 200 kiloradian per second. That means 2 pi f is 200 kilo. That means f is 200 by 2 pi kilo, and this will be equivalent to 200 divided by 2 divided by 3.14, that is 31.84 kilohertz. So this is greater than 11 hertz, right? What was the 11 hertz? From the first question, 11 hertz was the lower cutoff frequency. So the frequency is greater than 11 hertz, so the input capacitance will be shorted. But in the previous question, we found that upper cutoff frequency is 400 kilohertz. So this frequency of interest is less than that. Therefore, we need to use the CL. And note that I have ignored this capacitance, which is suppose that at this frequency that capacitance is also shorted. Okay, now we have this. What we need to find is gain. First, what will be V in? Can you tell me what will be V in? Let's say this is R in dash. So my V in will be equivalent to simple voltage divider R in dash divided by R in dash plus RS multiply Vs. So this will be my V in. Now, simple V out will be GM RC V in. Will it be? Did I do something wrong here? Will it be GM RC V in? or there will be something else as well. I did a mistake, right? Because now it's not only RC, we have capacitance in parallel as well. So this is incorrect. What we will do is this will be V out will be GM RC parallel XC L multiplied by V in. So this will be the formula. Alright. So V output by V in will be GL RC divided by RC plus XCL. Okay, is this correct? It's XCL. Okay. So what is XCL? 1 by j omega CL. So if I write it as a magnitude, so it will be Gm RC by omega CL multiplied by RC plus 1 by j omega CL. Alright. So note that in the denominator, I have not written the magnitude here. So V output by V in will be GMRC divided by. Now remember that if I write the magnitude of this, it will be like, okay, let me just first write it like this. Okay, so it will be mm, first write it J omega CL. Okay, this will be RC plus 1 by J omega CL. Here as well. Okay, this will be 1 plus J omega CL and J omega CL will cancel when I multiply it. It will be J omega CL multiplied by RC. Now, if I take magnitude of it, it will be G omega RC divided by, you know what is the magnitude of A plus iota B? A square plus B square square root, right? Square root of A square plus B square. Similarly, it will be under root of 1 square plus omega RC CL whole square. So this will be the magnitude. Now, V output by V input will be GMRC. What is GM? Did we calculate GM anywhere? Okay, GM we need to calculate. GM is from the formula IC by VT. And we have IC as we calculated it in the previous step. Would be okay, let's assume IC is equivalent to IE, that is 1.5 milliampere, because it's pretty close. So let's use the same 1.5 milliampere divided by 26 millivolts. So GM will be 1.5 divided by 26, that is 0.05, nearly 0.05. So we input, one second, is GM, that is 0.05, multiplied by RC. What is the value of RC? 4 kilo ohm, divided by 1 plus, and here in the denominator it is omega RCCL. Omega is 200K, RC is 4K, and CL is I guess 100 pico. Yes, CL is 100 pico. That is 10 to the power minus 12 multiplied by 100. That is 10 to the power minus 10 whole square. So you just need to calculate it. So this will be V output by V input is equivalent to 0.05 multiplied by 4K, that is 200, divided by 1 plus, this is 8 multiplied by 3 and 2 is 5, by 3 8, this is 10 to the minus 2 whole square, so this will be 200 divided by 1 plus 64 10 to the minus 4. So it will be around, let's calculate it, 1 plus, this is around 1, so V output by V input will be around 200. V output by V input is approximately 200, okay, but we need to find V output by Vs. So V in, we calculated here, V in is Rn dash divided by Rn dash plus Rs is 0, right? Vs, okay. And in the previous question, we found out that this is equivalent to 1.45 kilo ohm. So I can write here, this is 1.45K, Vs is nearly equal to 200, so the output by Vs will approximately 200 multiplied by 1.45. So this will be your answer. Okay, so this is how you find the gain using the capacitance and all in the circuit as well. So I hope that was easy to understand. If you don't have any questions, we can move to next part. Do you have any doubts? We have just 2 questions left for the session. Okay, so let me continue. The question says we need to find the effective input capacitance looking into the base of the transistor. Consider the effect of parasitic capacitances. Here the question says we need to take the parasitic capacitance into account as well. that are 20, 12, and 6 picofarad. Okay, I will discuss uh, some formulas which is from the Miller's norm. I hope you have gone through the lecture. So if you have component here, let's say this is Z, and you have an amplifier of gain A, then you can distribute it into two components. Sorry, this Z1 and Z2. The same happens with the capacitances. So from the equivalent circuit, we have, let's say this is RS C1 R pi, and there will be another capacitance here C pi, and there will be a capacitance between base and collector, that is C mu. Okay, the rest of the circuit. So what happens here is we use the Miller's norm to convert the C mu into input and output capacitance. We calculate its contribution to the input and the output capacitance. What are the formulas? Formulas are, let me just draw the circuit. If you have a capacitance say CF, let's say, and this is for amplifier of gain A, then C1, that is this capacitance at the input, will be equal to CF1 minus A, and C2, that is capacitance at the output, will be CF1 minus 1 by A. Remember these formulas? And you may have gone through the lectures. So these are the formulas to calculate the capacitances. Then using this formula for this question, we can write here as C in. What will be C in? Now C in is this capacitance here, that is C pi, plus the contribution from the mu, that is this capacitance, to this C pi, which will be like this. This will be C pi, and there will be a capacitance C1 here, which is given by C mu 1 minus A. And know that the capacitance in parallel add like this, right? The resistances in the parallel and the capacitance in the series are have the same formula. Similarly, capacitance in parallel and resistance in the series have the same formula. So this will be the formula for the total input capacitance. And your gain is simply minus GM RC. Know that here you don't need to take the main, you take it with sign. Okay, you have calculated it already. Oh, no, GM you have calculated, that is 0.05. RC is 4 kilo ohm. So this comes out to be minus 240. Just directly substitute it in the formula. C mu is known, C pi is known, A is known. You can calculate the C in, right? Just try it. The answer is around this C option. Just check that. Similarly, we need to find the upper cutoff frequency, but right now we need to include these parasitic capacitances. In the earlier question, what was done was we only use CL. Now there will be a capacitance, that is C out, which will be CL plus C2. And from the Miller's term, the C2 will be C mu times 1 minus 1 by A. That's what I written here, right? This this capacitance, which will act as a parallel of CL and the output. So calculate this. You know this value. You know A. You will find the total C out, and then use the formula omega R equivalent C out is greater than 1. You will get F upper is greater than 1 divided by 2 pi R equivalent C out. I hope you will be able to do it now, right? So this is the last we did, and if you need any help in the next tomorrow, we have a session tomorrow. I will show the derivation for the Miller's term. Okay. So if you have any doubt, you can ask me before we end the session. This was the last question for this session, and we will meet again tomorrow. Okay. Do you have any questions? Okay, then we can we can end the session and see you tomorrow because we have a session tomorrow as well at the same time, 6 to 8. Okay, I will end the session now.